Two truths and a lie, but with math. Can you spot the fake? First fact, draw a right triangle with whole number side lengths, then draw the largest possible circle that fits inside. This circle will always have a whole number radius. This works for any Pythagorean right triangle. Second fact, pick two random points on a line segment, then find the distance between them. On average, this will equal half the line segment's length. Last fact, shuffle a full deck of cards, then pick one at random and make sure it's not a joker. On average, your card will be between the two jokers 1 in 3 times. Pause now to think about which fact is fake. The third fact is true. Let's say you picked the 16th card and the 7th and 40th cards were jokers. Now there's an alternate universe out there where you picked the 7th card and the 16th and 40th cards were jokers. And there's yet another alternate universe where you picked the 40th card and these two were jokers. But there are more universes, 3 more that correspond to positions 7, 16, 41, and so on, 3 universes for every possible trio of numbers. Now notice that in every trio of universes, exactly one has the joker sandwich that we want, so it'll appear 1 in 3 times, which is what the fact says will happen. The second fact is false. To make things easier, we'll choose from 11 points instead of infinitely many. So the minimum distance is 0 and the maximum is 10. So on average, your distance would be 5, right? No, because there are more possibilities for shorter distances. For example, there are 10 segments of length 1 but only 2 segments of length 9, so you're more likely to end up with a distance that's smaller than 5. The same idea works for infinitely many points, so the average distance is actually 1/3, not 1/2. There's a more clever solution that involves adding an extra dimension, but I won't get into it because it is harder to understand. The first fact is true. Some clever algebra gives us this formula. Now suppose a and b are even, which means a squared and b squared are also even. Adding them together gives c squared, and if that's even, then so is c. Adding and subtracting even numbers will always get you another even number, so the numerator is divisible by 2. The other 3 cases follow similar logic, so the radius is always an integer. Comment whether you got it or not.